Okay, good morning. We are going to get started now, and we are going to take a look at what we would call Chapter 24. That's a holdover from other textbooks. We're going to be looking at metabolism inside the cell, and most of your textbooks, regardless of your source, are going to all say, have it somewhere in the back of the book. And we like to teach metabolism now after we've done the cell, because the process of obtaining energy from glucose, obtaining energy from the cell to do things is so important to have a basic understanding of it. But we're also going to spend time this morning talking about nutrition and how the cells are going to, we talked about those biological molecules, so fats and proteins and carbohydrates. And today we're going to talk about why they're so important. Now, lab this afternoon, I'll throw a few housekeeping facts out there. Lab this afternoon, we're going to take a look at joints and articulations, and we're going to start looking at the skeletal muscles. And there is no, and in Wednesday lecture, we will hopefully finish chapter 20, finish this unit, I hope, but if not, we'll finish it after break. There is no class next week. I'll tell you that right now. Next week is spring break, and no classes meet, whether you're on ground or online. So you can enjoy Monday through Friday of next week as spring break. So, okay. Any questions on anything? Okay, and I'm going to go ahead and get us into this chapter on nutrition and metabolism. Let's get that out of the way. There we go. Okay. So to understand nutrition and metabolism, we have to understand, oh, we got a comment, sorry. Last class, we finished up the section on protein synthesis. Yeah, if you go to the video, it would be the video from the 23rd of February. And that will cover protein synthesis, how we make protein using DNA as the instructions. So, okay. Nutrients. Oh, did I answer that? Okay. Next lecture test. Good question. When I finish this chapter, we can schedule a lecture test after that. So can't do it till I get this chapter done. So it'll be sometime after spring break. That's the best I can say right now. Okay. Nutrients. Something we need to survive. It is a food substance. It can be protein. It can be carbohydrates. It can be lipids. We need all of those to survive. We also need vitamins and minerals. We need vitamins to help with enzymes as coenzymes, and we need minerals for bones, calcium for bones, phosphorus for bones and teeth. We need iron for hemoglobin. All these things, these minerals that we need in our bodies for various functions. And the last nutrient is water. Water is a nutrient. 60% of the food that we eat is water. Our bodies are 70% water. Without water, we'll die in 3 days. But we're not going to be we're going to usually probably be in some sort of psychotic break after the second day. And so our ability to function or even find more water after the second day of no water is very limited. So now this is what the Department of Agriculture will call the food pyramid. And it's supposed to be a way to graphically represent what should we eat a lot of and what should we eat a little of. And so at the bottom of the pyramid are the extremely healthy foods, like the whole grain foods, and that we should be eating, like whole wheat bread, whole wheat muffins and rolls, foods that are high in fiber, and the types of fats that we should have in our diet, the cooking oils, olive oil or corn oil or even peanut oil, as well as fruits and vegetables here. And we work our way up to the top of the pyramid where the things that we should eat in limited amounts, the processed foods, white rice, white bread, lots of pastas, lots of sugary foods, lots of animal fat, and lots of meat. We should try to limit consumption of those. Doesn't mean we can't eat them. We have a truly balanced diet, has mixtures, has combinations of all of these in here. What this pyramid is attempting to show is that the meat and potatoes diet that was predominant in the U.S. up into the 1960s is not a healthy diet. During up until the 1960s, maybe even the 1970s, the primary evening meal was a meat and potatoes based diet, red meat and a starchy potato in some form. And there's nothing wrong with red meat. There's nothing wrong with potatoes, but every day, the same variation on this kind of diet. And if you go back and look at the levels of heart disease in the United States up through the 1960s and 70s, they were climbing every year with easily 500,000 people dying from heart disease. And a lot of that was driven by diet. And since the 1970s, the numbers have stayed constant. The number of people dying from heart disease every year stays around 500, 600,000 people, but our population has almost doubled. So we're obviously something is being done well where we eat healthier foods. There's nothing wrong with meat and potatoes, but not as the same variation of that every night. So collectively, the population of this country eats healthier than it did 50 years ago. So anyway, enough of that. So what does nutrition mean? Nutrition is the overall impact of all the nutrients we take in and how we use them as a fuel. We convert most of our nutrients into ATP. We break them down like the carbs. We break them down to glucose, and we use that to power ATP production. ATP is the molecule we use to send energy around the different parts of our body. We can do the same thing with fats, and we can do the same thing with proteins. We measure the amount of energy in our food using the term calorie. We all know that. It's actually what we call a kilocalorie. 1,000 calories is one big calorie. So what you're seeing reported on a package, a nutrient package, it says how many calories. That's based really on kilocalories. Don't get hung up on that. So, but what is a calorie? It is a specific amount of energy. It's the amount of energy necessary to raise 1 kilogram of water by 1 degree Celsius. That's a lot of water, and that's a lot of energy. So, but calories are what we measure, usually what we focus on when we're looking at food items. An apple is 60 calories, a potato is 60 calories, a slice of bread might be 80 calories. A quarter pounder is 360 calories, I think. A bottle of Coke is 220 calories, as are most soft drinks of that size. So a Frappuccino from Starbucks, fully loaded out with all the whipped cream and all the syrups and toppings and drizzles, is about 1,500 calories. So what does that mean? Well, that a calorie represents the potential energy stored in the valence shells of the various molecules that make up the ingredients of that food item. Carbohydrates, lipids, and proteins have covalent bonding that takes place between the molecules at the valence shell. Valence electrons have lots of potential energy. It's the potential energy that we report as calories. So a Snickers bar may have 180 calories of potential energy there based on the valence electrons holding all those molecules together. You didn't know you were eating a chemistry experiment when you ate a Snickers bar. So let's take a look at carbohydrates. This is the, who doesn't like carbs? I'll just say that, throw it out right now. Most of our carbohydrates come from plants, the sugars that we find in our foods, the mono and disaccharides. Now, we usually ingest food in the form of sugars in the form of disaccharides like table sugar. Sucrose is table sugar. There's two types of sucrose. There is cane sugar, comes from the sugarcane plant, and there's beet sugar, comes from the sugar beet. They look the same, they taste the same, they are identical. The only way you can tell the difference is on the packaging, because cane sugar comes in a package that says pure cane sugar, and sugar beet sugar comes in a package that says pure sugar. Other than that, there's no difference. There's no difference in the price or the appearance or the flavor or anything. Now, the monosaccharides, the glucoses, often show up in soft drinks. Fructose shows up as a sugar in soft drinks. High fructose corn syrup is what we get when the sweetener we have in a Coke, for example, or a Pepsi. Cane sugar or beet sugar in soft drinks has, sugar hasn't been used in soft drinks for 20 years. It's all high fructose corn syrup. It's less expensive. Now, what about fruits? We get, depending on the age of the fruit, we may be getting sucrose, we may be getting glucose. As a fruit ages, the complex sugars, the starches, because that's what's inside. You get an apple or a banana, and it's made up of starchy. The fruit inside the skin is a starchy fruit, and eventually, over time, the apple will get mushy as the fruit. As the starch breaks down to sucrose. If it stays mushy long enough, it will be converted to glucose and be very, very sweet. There's a whole disagreement about bananas. Do you eat bananas that are green? Or do you eat bananas that have big brown spots on the yellow skin? Or has turned brown completely? Because when the banana is not ripe completely, but is firmer, that's when it's you get a green banana. Some people love to eat bananas when they're green. Other people like them when there's lots of brown spots on the skin because they are sweeter. That's the type of banana you would use in baking to make banana bread or banana muffins or something, or banana cake, something like that, because it's good and sweet. But they're, when you're eating a mushy banana, it somehow loses the same appeal, no pun intended there. So why do people like the banana that has the skin has turned dark brown? It's sweeter, and maybe that's what they grew up with. So we have a whole disagreement in our division here in Sevierville in natural sciences. Dr. Grice and I like the bananas when they're still green. Jillian, our lab coordinator, likes them when they're brown. Both, she thinks that we're crazy and we think that she's crazy, but that's a whole other story. Anyway, the sugars, the naturally occurring sugars that we find in fruit and vegetables, are starch. It's a polysaccharide. Given enough time, that starch will break down to glucose. And we see this in our potatoes. We see this in our carrots. We see this in our beans and our peas. We see starches in all of our cereal grains. We see it in our fruits, apples, for example. What's inside a corn kernel is starch. What's inside a potato? Starch. What's inside a carrot? Starch. What's inside a leafy green plant? Starch. So what do we get in our cereal grains like corn flakes and whole wheat flakes or Cheerios? We get starch in here. Now, one thing about plants is that plants also produce another type of polysaccharide. Now, they make starch. That's what plants do. Plants convert sunlight, use sunlight and carbon dioxide and water to make glucose, which gets stored as starch inside the plant's leaves or in its roots. That's your, general biology lecture for today. We eat apples, we eat potatoes, we eat carrots, and we're getting the starchy content in the middle here. Surrounding this is usually there's an outer layer. If we're eating whole wheat, we're eating the starchy portion, plus we're also eating the bran. The outer covering of the wheat kernel or the oat kernel or the corn kernel is the fibrous portion. It's made out of cellulose, which is also a polysaccharide like starches, but we can't digest it. We can't eat cellulose. We can't go chew on a leaf and get anything out of it. Even eating salads, the outer covering of the leaves that are made of cellulose, we can't get any nutrients out of that. What we get is the starches inside the plant. So, but we do get fiber. We call it roughage. We get fiber. Fiber is healthy in our diet. Fiber helps to keep our colon cleaned out, if you will. Consider the effect of someone who has 2 bowls of Raisin Bran for breakfast and maybe a couple of bran muffins on the way to school. You're not going to see much of them during the morning because all that fiber from the bran cereal and the bran muffins are going to keep them occupied, keeping their colon cleaned out. When it comes to digestive fiber like that, a little goes a long way. Bottom line in all this is glucose is the carbohydrate that we use. Glucose is the carbohydrate that powers our cells. We use glucose to make ATP so we can get things done. And all of our cells depend on glucose. So we eat carbohydrates. Carbohydrates are a very convenient way to get glucose. Carbohydrates contain 4 calories per gram of stored energy. Carbohydrates contain 4 calories per gram of stored energy. So we like to eat carbohydrates. It's a convenient way to get glucose to us. 4 calories, that's how much in a gram of carbohydrate, that's how much potential energy is available to us. So how many grams a day should we eat? Well, generally we suggest that about 100 grams per day is the minimum. 100 grams per day is the minimum. However, the recommended amount is somewhere in the neighborhood of about 175 grams on a daily basis. So that is, maybe 2 slices of bread, a potato and an apple, for example, a bowl of cereal for breakfast, and a baked potato at supper, for example, as your carbohydrate intake. That doesn't mean that's all you eat during the day, but you need to eat other food sources, you know. And the carbohydrates that you do eat need to be what we call the complex carbohydrates. Those are the polysaccharides. You know, it's better to eat, it's healthier to eat an apple because the starches inside the apple are a polysaccharide than to eat a Snickers bar. Even though we see in the commercials, it's, you know, you're not yourself if you don't eat a Snickers bar. Remember the old Betty White commercials that were on a couple of years ago during the Super Bowl? She ate the Snickers bar and she changed. Well, what it's implying there is the Snickers bar is providing energy. Yes, it's providing energy. It's providing energy in the form of sucrose, table sugar, as well as a certain amount of fat and protein. You know, if you're going to have a snack, a Snickers bar is not a bad snack because the peanuts provide protein. They also provide a certain level of fat from the oils. The chocolate and the caramel inside the Snickers bar is going to give you a certain level of sucrose in here. So it's not a bad snack. The only downside of the Snickers bar is you're getting a lot of calories that are short-term calories. Complex carbohydrates give you calories too. 60 calories from an apple, for example, it takes longer to break down the starches inside an apple than it does to break down the sugars in the Snickers bar. And so the complex carbohydrates give you a longer lasting effect, whereas the simple calories, the simple carbohydrates that you would find in a candy bar are going to give you a rush of sugar, a rush of energy, and then it's going to tail off quickly. It doesn't have any it doesn't have a long lasting effect. Not knocking Snickers bars, I like Snickers bars. As far as a food source, there are better choices. So now what about how much do we need? We need 170 grams of carbohydrates a day. If we take in less than 50 grams, we start chewing up fat and then protein, which may not be a bad thing. If your patient's trying to lose weight, for example, then you advise them that, well, maybe if you can minimize your carbohydrates, you'll start burning more fat, and say it in a nicer way than that, you know. But if you can minimize the carbohydrate intake, it'll force their body to start breaking down more fats. And fats are a great source of energy. They have 10 calories per gram than as opposed to the 4 calories per gram that carbohydrates have. If we get less than 50 grams of carbs a day, we'll start breaking down the fats and then maybe the proteins. But you know, we'll start seeing weight loss in your patient by breaking down their stored fat. The problem in the United States is that while we're supposed to have about 175 grams of carbs a day, typically we take in more than 300 grams of carbohydrates. So we usually have double or triple the amount of carbs we need, you know, because carbs taste good. We like carbs. You know, who doesn't like breads and pastas and you know, sugary foods? You know, who doesn't like a donut from Krispy Kreme or a Snickers bar or a Coke? You know, a lot of those calories in there give us more energy than our bodies can use. So there's nothing wrong with any of those. It's just in how often do you have a Coke and a Snickers bar, you know, or, you know, you go to Krispy Kreme or Dunkin' Donuts and have a donut and say, oh, if one is good, let's have 2, you know. I like donuts. I like Snickers bars. I like Cokes. But you have to try and moderate that. You have to advise your patients to moderate that, because you need to make sure your patients understand that you have to have a balance in the food they take in. Many healthcare providers will recommend that if a person wants to have a safe, healthy weight loss, is to cut their carbohydrate intake to down about 100 grams a day. And that will cause a gradual weight loss over time. It won't cause any drastic methods. It won't cause any, I can't eat that, it's evil. No, I can't eat that, it's evil. No, it'll just, your patient will see a nice, gradual, slow weight loss in here, just by cutting back on the carbs. Healthcare focuses a lot on eating fats, but it's actually the carbs are probably more of a health issue than we realize. Okay, moving on. Complex carbs. What are the complex carbs? They are the breads, the cereals, the crackers, the flour, the pasta, nuts and rice and potatoes, things that take time to break down, things based on starch. Foods based on starch, they're usually high in vitamins, high in minerals. They are polysaccharides. And so to get them down to glucose, we have to break the polysaccharide chain down to disaccharides and then down to glucose. And that takes time to go to release all the energy stored in a potato. We don't just surge it out at once. If we eat something that's made of sugar, we break that down to glucose right away, and we get lots of glucose, and we make lots of ATP, and we have this sudden surge of energy, and then we crash afterwards. But the complex carbs take more time to go through. That's why we like the complex carbs. We need to avoid, or need to tell our patients to avoid, the foods that are significantly processed. That we say they have empty calories in there, like a Coke. Who doesn't like a Coke? Or Pepsi or Mountain Dew, or any kind of whatever your favorite beverage is. They all taste good. They wouldn't be our favorite beverage if they didn't taste good. But the flavorings, the sweeteners in our drinks are usually either simple sugar. They're simple sugars, either going to be monosaccharides like fructose in our soft drinks, or they're going to be sucrose, the disaccharide, the sweetener we put into our coffees or in our candies, or the fruit that has broken down its starches into the simple sugars in here. Ice cream, full of simple sugars. Does that mean don't eat ice cream? No, of course not. Just how often do you eat it? Do you eat it every night? Do you eat it every day? Most of us have most of us probably have a Coke every day. Is there anything wrong with that? No, of course not. How many Cokes a day does your patient drink? Again, you have to advise your patient how much do you eat at a time. Now, here's one that always throws me when I see this: the immature vegetables. For example, if you like to go to a Chinese restaurant, and many of the vegetables there, they have the little tiny ears of corn and other vegetables that are not mature. They have not laid down a lot of starches inside them, and so they're mostly simple sugars, and they're not nutritious for us. Yet they taste good. The problem with these processed foods is the calories are empty calories. They have been refined to the point that they're not offering a lot of nutrition for us. They taste good. We like them. But if we have a diet, if our patients have a diet high in refined sugary foods, they're going to have nutritional issues. We're going to talk about this in AP2. We're going to talk about the surge in diabetes, what many people would refer to as sugar diabetes, based on a diet high in carbs, and low in fats and proteins. Your patient that maintains a diet high in sugary foods will probably experience significant weight gain, which can lead to obesity, which can lead to heart disease, which can lead to diabetes, which can lead to hypertension, and shorten their lifespan and shorten their quality of life drastically. We see a lot of issues of obesity and heart disease and diabetes in Tennessee and all across the Southeast. Okay, now, so that's the carbohydrates. Let's take a look at the lipids. The lipids are the fats. We know that from chapter 2. Your typical lipid, the triglyceride, is 3 fatty acid chains attached to a glycerol, and the fatty acid chains are either saturated or unsaturated. And this is why fats have so much stored energy, so much potential energy. Look at all the valence electrons. We can't see the valence electrons. Look at where all the covalent bonds are between the carbons and the hydrogens on each of these chains. And that all those valence electrons are the source of the potential energy we have here. So fats are essential. A person who says they're never going to eat fat again in their diet that person is making a serious health mistake, because fats are essential. We have to be, without fats, a whole series of vitamins can't be absorbed in our diet. All the vitamins are either water soluble or fat soluble. We don't eat fat, we can't absorb the fat soluble vitamins that we need, like vitamin A and vitamin E and vitamin K and vitamin D. All these are fat soluble vitamins that we have to have. Our liver cell and our muscle cells use stored fat as a quick source of energy. We use fats in our cell membranes. We use fats to insulate our nerves. There's a layer of white fat around all of our large nerve cells called myelin, and that is the insulator. And so our nerve impulses don't essentially jump the tracks. We also have to have cholesterol for hormone production. Remember, we have a whole set of hormones that are made of steroids. All the sex hormones are made of cholesterol, estrogen, testosterone. There are a whole series of hormones that you'll learn about in AP2 from our adrenal glands that are based off of cholesterol. So cholesterol, again, cholesterol is not an evil chemical. We have to have a certain amount of cholesterol in our diet. If we don't, we'll be making it, so we can't avoid it. So how much fat should we take in on a daily basis? We should be taking in about 600 calories worth of fat. The average the average calorie content for an individual should be about 2,000 calories a day. That's based on a typical person involved in some sort of a sedentary occupation where there's a certain level of physical exercise, but not you're not the extreme where you never do anything. You're sitting in a chair, actually you're probably sitting in a recliner, or you're working construction. Somewhere in the middle is what we would refer to as the sedentary occupation. And so you're going to burn about 2,000 calories a day. So that's what we burn altogether. Now, how much of that 2,000 calories that we burn should come from fats? About 600 calories, or about 30%. So for most of us, our fat intake is probably closer to 40% or 50%. So we try to avoid a high fat intake in our diet if we want to try to stay healthy. And of all those fats, we need to because some fats are saturated and some are unsaturated. We try to limit the saturated fats to less than 10% of that intake. So how much cholesterol should we take in? About an egg a day. The amount of cholesterol in an egg yolk is about 300 milligrams. That's about what we should get every day. Doesn't mean I got to eat my egg a day. It means that that's the equivalent 300 milligrams is what we should take in. You know, and eggs have gotten such a convoluted history here on, are eggs good or bad for us? You know, from the 1990s, you know, and 80s, eggs good, eggs bad, cholesterol good, cholesterol bad. Avoid eggs at all costs. Eat eggs when you want to. You know, it's gone back and forth. You know, to where now it's about an egg a day, an egg every other day is perfectly fine. If you eat a couple eggs for breakfast one day, that's probably just fine. You know, in the United States, you know, I remember when I said about the meat and potatoes diet for supper. Well, the breakfast of choice for many, many, many people for many years, up until the 1970s and 80s, was bacon and eggs for breakfast every day. Bacon, eggs, toast, and coffee. You know, a very tasty breakfast, but not necessarily a healthy breakfast, because you were getting a lot of saturated fat from the bacon and a lot of cholesterol from the eggs. And while it was a taken by itself, it is a healthy breakfast. But if it's done every day, and that just contributed to the health issues of many Americans into the 80s, in the 1970s and 1980s, because most of the fats involved in the bacon and in the cholesterol were saturated fats, and saturated fats contribute to heart disease by increasing the levels of the low density lipoproteins. The low density lipoproteins, the bad cholesterol, take the cholesterol to the cells from the liver, and what the cells don't need, it ends up getting deposited in arteries and veins and starts blocking those arteries and veins. And heart disease was a major health issue and still is, you know, up until, well, I guess it still is, but the number of people dying from heart disease has stayed relatively stationary while the population has increased. So, okay. Where do we get the fats? Well, animal fats, you know, lard. We use lard as shortening for you know, biscuits and pie crusts and pastry shells and stuff like that. We cook with it. We use lard mixed with sugars to make frosting. We have animal fat in our meat. We have it in our poultry, in our eggs, in our milk. Whole milk is 4% fat. Now, that's not very much. And so many people will swear that I'll never drink whole milk because of its high fat content, but it's only 4% fat. Skim milk is 0% fat, you know, and then that's what the 1% and 2% mean. So you're not gaining a whole lot if you go from whole milk to 2% to 1%. You know, the amount of fat in whole milk is negligible compared to other sources of fat. Anyway, but again, no, they are saturated. Doesn't mean you can never drink whole milk. No, just how often do you drink milk? You know, for most of us, the only milk we get is if we have cereal. Sources of fat from plants include, I hate to say this, but chocolate and the cooking oils, the corn oil, the soybean oil, cottonseed and olive oils, coconut oil. All of these are sources of plant fats. Seeds and peanuts and nuts are all high in fat, but they are usually unsaturated. If you look at a jar of peanut butter, you can see that peanut butter is very high in unsaturated fats and may have no saturated fats in there. And of course, cholesterol comes from eating animal meats, animal organ meats like the liver. You know, some people like chicken livers, some people like beef liver, some people like to eat kidneys. You know, if you like to eat shrimp or lobster, they're going to be high in cholesterol. You know, for whatever reason, that this is sort of like, you know, if you like crab meat, if you like lobster, if you like seafood like that, if you love shrimp, it's the kind of thing where it's going to be relatively high in cholesterol, as well as the liver and kidney of a cow. Some people eat brains. Some people will eat fried animal brains. And again, it's very high in cholesterol. So why do we need cholesterol? Well, cholesterol makes up our steroids, makes up our steroid hormones. Cholesterol forms the reinforcing structure of our cell membranes. The high density cholesterol, the HDLs, transport cholesterol away. We use that. If we have excess cholesterol, the high density lipoproteins take that cholesterol back to the liver for destruction, but we still need a certain amount of cholesterol in our diet to keep our cells healthy. The sex hormones, testosterone and estrogen, are based off of cholesterol. The bile salts that show up from our liver going into our gallbladder to break down fat in our small intestine are made of cholesterol. So we get cholesterol in our diet, we get fats in the form of triglycerides, in our diet. So if we eat fat, where does it go? Well, we tend to store the fat in the adipose cells. Some of our organs don't have any kind of protection, like our kidneys have no protection, but they have a cushion of fat around them. We have a layer of fat underneath our skin as insulating material. We have fat deposits in our skeletal muscle cells as a great source of energy. As I said, a gram of fat gives us 10 calories of energy. Carbohydrates only give us 4 calories of energy. So the muscle cells, skeletal muscle cells, will have a lot of fat deposited around them. It's the same fat that we see when we buy a piece of meat at Food City, and we have to trim the fat off before we cook it, because that's what it's supposed to be there. We just dissected cow hearts in AP2 in lab, and every one of the cow hearts, and you'll get your turn in AP2 to cut up cow hearts. Every one of those hearts had large deposits of fat around the heart. So I'm not saying the cow had heart disease, but that's what the cow had. A lot of organs in our bodies aren't protected by anything. Now the heart is, but that's beside the point. We accumulate fat around different locations in our body. It's a great source of energy. It's, as I said, for some organs, it's the only way to protect them. So what about fat? We chop up fats in our when we eat fats, we chop up fats into very small particles in our small intestine. And we break them down to fatty acids and what are called the monoglycerides. We chop the tails off of the, we'll chop off 2 of the fatty acids off of the triglycerides. Fats show up as triglycerides, the alcohol and 3 fatty acid tails. What we'll do is we'll chop off 2 of the fatty acids and leave 1 attached. So we'll have a monoglyceride. And then after we chop them up into little pieces, we'll put them back together as a triglyceride. And we use the high density and the low density lipoproteins to transport the fats around the body to where we need them. The low density lipoproteins end up taking the fats and cholesterols from the liver, where we clean everything up, takes it from the liver out to the cells, and the excess gets deposited there. The high density lipoproteins will bring the excess back to the liver for destruction. We like to have high levels of the HDLs and low levels of the LDLs, so we don't have too much fat accumulation around or inside our arteries and veins. So problems with fat. High-fat diets can lead to obesity. It can lead to heart disease. When we bring fat to the cells and the cells use what they need and the leftover is then taken, finds a home inside our arteries and veins, we form something here. This is called plaque, what you see inside the artery. This area in here, all this yellow stuff, is called plaque. That is fatty deposits in here. We narrow the artery. It causes a risk of heart disease and heart attacks and reduced lifespan. It also can cause strokes in the brain by blocking the cerebral arteries that supply the brain. And again, we have some significant damage. A person who has maintains a high-fat, high-carbohydrate, low-exercise lifestyle runs the risk of developing obesity and heart disease, as well as diabetes, and hypertension. Because if you reduce the flow of blood through a vessel, your heart has to work harder, and it causes the harder it works, the more blood pressure goes up. We don't like that. So now something else that happens to us if we eat a lot of cholesterol, particularly from animals, we run the risk of developing Creutzfeldt-Jacobs disease. Now, Creutzfeldt-Jakob disease is what we call, it's the human version of mad cow. Bovine spongiform encephalitis. Your brain rots if you become infected with this. It can't be treated. It's not something that cooking the meat will prevent. It is number of people that die every year from mad cow disease, from bovine from Creutzfeldt-Jacobs in the U.S. is about 3 or 4. But we haven't had a case of mad cow disease in the U.S. Yet, and we haven't had many cases of humans developing it from eating cow meat, but about 3 or 4 people a year die from this. But if you've ever heard of chronic wasting disease, that is the deer version of bovine spongiform encephalitis. Now, how many people like to eat deer meat? Yeah, quite a lot. Quite a lot of people like to eat deer meat. And whether it's ground as ground venison or venison steaks or venison stews, the agents that cause Creutzfeldt-Jacobs are present. And we now know, well, let's put it this way. When I came to Tennessee in 2004, there were few, if no, cases of chronic wasting disease in deer in Tennessee. Now, 18 years later, we find numerous counties are all reporting around the state that deer have chronic wasting disease. And so they can't be eaten. They can't be processed. They can't be cooked. They have to be disposed of safely. So because of this. Now, what about doing something about the fat we take in? What about a fat substitute? We like fats in our food because they make food taste better. They make the foods more palatable. When we eat something, the food, if it has a high fat content, it has a smoother movement around the inside of our mouth. We pick up all the flavors better. It tastes creamier. We like fat. Butterfat is a measure of the quality of ice cream. When you go to Food City, for example, and they advertise, they have their ice cream there, and they advertise it as this particular type is a premium ice cream. That's just not, advertiser talk. Premium is a grade of ice cream, and it's based on the butterfat content. The higher the fat content, the better the ice cream is. Now, like Baskin Robbins and Marble Slab and any other ice cream store is going to have, ice cream that's high in butterfat. It tastes better. the more fat we have in a food product, generally the better it tastes. And so the ice cream is creamier. It is more pleasing to eat. It moves around inside our mouth better. It's lubricated better because of the fat. And so we like that. So how do we get around the fact that excessive amounts of fat are not good for us? Well, how about a substitute? Something to reduce the amount of fat we take in. Now, air, believe it or not, is the oldest and most frequently used fat substitute. We whip foods together. Whipped cream, for example, is nothing but heavy cream and air. My wife makes homemade whipped cream all the time. You just whip it together with a mixer, and it gets very fluffy. And it's essentially the same thing that comes out of a can of Ready Whip. All it is cream and heavy cream and the fat in the heavy cream. That's why they call it heavy cream, and air whipped into it. So maybe you might, add some flavoring to it, but maybe not. So it is significantly healthier than the various chemicals used in a container of Cool Whip. Because while Cool Whip tastes like whipped cream, it has a lot more chemicals in there to give it stability and flavor. Just my personal bias there. So that is the earliest type of fat substitute. We've also used various gums and starches. We've added starch to food to replace fat. That adds calories. Various gums, it's like a gooey mixture to give it some sort of texture. A lot of certain types of gums come from seaweed. Many types of ice cream have something called carrageenan in them, and that comes from seaweed. There's nothing wrong with it, but it helps to reduce the amount of fat in the ice cream. The problem with all of this, and whey protein. Whey protein is a product of production of cheese and dairy product. So you add that into the ice cream. It adds calories. And if you're trying to avoid the calories from fat, it's not helping by adding these calories back in. The last effort to make an artificial fat took place, probably 20 years ago, more or less. Frito-Lay developed the big chip company, developed a synthetic fat. It was called a sucrose polyester. It was a fat substitute that would do everything a fat would do. It would lubricate the food in your mouth and make it taste good, but it wouldn't add any calories because the sucrose polyester would not be absorbed. And Frito-Lay came out with a whole line of food, chips and crackers and pretzels and Doritos and Pringles that were marketed under the name Wow, because Wow would be, hey, I can eat this all day and I'm not getting any fat. The active ingredient inside here, the sucrose polyester, went under the brand name of Olestra. And up until a few years ago, you could still buy, I sort of gave it away there. Up until a few years ago, you could still buy Frito-Lay products with Olestra in there. But I've done a non-scientific survey, at least of Food City, and I couldn't find any cans of Pringles with it in there. The problem with Olestra, it worked great for about 60% of the population. It was a fat substitute. It worked fantastic. The first problem was that you couldn't cook with it because it broke down at 300 degrees, and you need about 350 to cook French fries. You need it at 350 to fry anything. So the problem with Olestra is that it caused abdominal cramping and loose stools, which is another way of saying explosive diarrhea, unannounced or explosive diarrhea. And your person would suddenly discover that their bowels had just emptied. You see the picture here of what happened here without warning in about 30 to 35% of the population. You know, you can see how they market it under Pringles and under Lay's. Half the calories, because all the fat, you know, half the fat wasn't being absorbed. It had a real bad effect on on individuals' colon, large intestine. And so you know, 30% of the people that ate this stuff would suddenly have explosive diarrhea without any warning, and a lot of cramping. And it's unfortunate because it was a good faith effort to try and produce a product that would not, that they could market their snack foods without dealing with all the extra calories. Now, since then, one of the things that has really improved on fat is the use of air fryers. You know, air fryers, you probably all use air fryers or been associated with them. You know, you use very, very little oil, and by circulating the hot air around the food with the very thin coating of oil, you use practically no oil to fry your food. And it has all the benefit of the fat without any of the calories. You know, instead of using a half a cup of oil, you use a teaspoon of oil, and then you recover about half that. So, you know, perhaps the way to eliminate the use of fat is to use a new type of cooking device. And I know that many people use air fryers. And my wife's been using an air fryer now for about 6 or 7 years, and they work great. But this was the problem. You know, it wasn't that Frito-Lay didn't study this, but it wasn't their test subjects. You know, it was the luck of the draw that their test populations they sampled this on apparently all belonged in that 60% of the U.S. population that didn't have a problem with it. The last time I looked, prior to this year, you could still buy Pringles with Olestra in it. Kroger used to have it. Food City doesn't have it now, unless they have it in some secret location in the store. Haven't looked at Walmart to see if they've got it. So I always try to look and see if they're still marketing it or not. So, okay, now, third category of nutrients are the proteins. Proteins are coming from eggs and milk and fish and all of our meats. These are what we call complete proteins. Animal sources of proteins are complete. It means that they have all 20 amino acids present. So if you eat a piece of meat or chicken or fish or cheese or an egg or drink milk, you're going to get in your proteins that you ingest all 20 amino acids. And we can chop those we can break those amino acids, those proteins down into their individual amino acids, and then turn around and use those to build our new amino acids, to build our new proteins with those amino acids. So you eat beef protein, you eat a piece of beef, and we process those amino acids down, where we break them apart, and then we use those to make our new protein. You may eat a piece of chicken, and then it turned that into the protein that goes into a skeletal muscle or into an enzyme. Plant proteins are incomplete. Plant proteins there is no plant protein that has all 20 amino acids. Every plant protein has a different mix. You know, the legumes, the beans and peas have plant proteins, but not all the amino acids. Nuts may have proteins with amino acids, not the same mixture as the beans and peas do. The cereal grains, the corn, the wheat, the oats have amino acids, but not the same as the nuts and the legumes. So we say that these are incomplete proteins. Now, how do you fix that? Well, it's very simple. You combine the plant food sources, usually beans and legumes and cereal grains like beans and corn, beans and rice, those are two good combinations of legumes. Beans and peas are cereal grain, are legumes, and the cereal grains are the rices and the wheats and the oats and the corn. And you combine corn and beans, rice and beans, for example. This will give you all 20 amino acids just by simply combining the food. So if if you have a patient who is a vegan or a vegetarian, all they have to do to get their complete set of amino acids in their proteins is to combine their foods: corn, beans, rice, and legumes. Easy combinations. What do we use proteins for? Well, obviously structural and functional. We use it to make keratin, our waterproofing material, collagen fibers, the strongest, the most abundant protein we have, stronger than an individual strand of steel. We use it for elastin, the elastic fibers, and of course our muscle proteins, what we call the actins, the contractile protein, the actins and the myosins. Our functional proteins include the enzymes and our hormones. Most of our hormones are going to be protein-based. How much protein should we take in on a daily basis? Don't worry about the 0.8 grams per kilogram of body weight. 50 grams of protein a day. 50 grams of protein a day is the recommended standard. Of protein. Proteins, to make a protein, we follow the all or none rule. Unless we have all the amino acids present, we're not going to make the protein we need. So it's generally not a problem if you are eating complete proteins, because you'll have all the amino acids. Beef and dairy and fish and chicken, all your animal source proteins are going to have all 20 amino acids. Your plant proteins are not. So if you want to, the problem here is if your individual is not eating a combination of different types of plant proteins, then their body will suffer by not producing the protein, not making the proteins they need, because they'll be missing an amino acid. And if we're even missing one amino acid necessary for the protein, our bodies don't make the protein. So that's the all or none rule. Now, and we talked about how we can break down carbs for energy, we can break down fats for energy, we can break down proteins. The term gluconeogenesis, the creation of new glucose. Neo means new, genesis means creation. The creation, gluconeogenesis, the creation of new glucose. We can convert carbohydrates to glucose. We can convert proteins to glucose. And we will, proteins are the last to go. Once we burn through the carbs and burn through the fats, then we go after the proteins. Now there's a term here called nitrogen balance. Nitrogen balance is the state that we're in if the amount of protein synthesis, making proteins, is balanced by the breakdown of proteins. Because muscle cells wear out, hormones wear out, enzymes break apart. So we have to replace that protein all the time. So as we're breaking down our protein, we are building it back up with new protein. Protein synthesis is equal if we are in balance, we are breaking down our protein as fast as we're making protein. We are in a positive balance if we're making more protein than we're breaking down. Children are growing. If you feed children, they're going to grow. And they're going to grow rapidly. They are in a state of positive balance. They are making more protein than they're breaking down. People that are undergoing, recovering from some sort of tissue repair, and recovering from an injury are going to be in a positive balance. Negative balance occurs if we're breaking down our protein faster than we're building it up. A person under a great deal of stress, a person who has suffered severe burns, a person who is fighting a severe infection of some sort may be in negative balance. A person who isn't eating right may be in negative balance. A person who is not getting enough protein on a daily basis may be in negative balance. We can control our protein synthesis through our endocrine, our hormonal system. Growth hormone, we get lots of growth hormone released into our bodies when we hit puberty. We have rapid body growth. We have we hit our adult stature very quickly in just a few years after going through childhood, where we have incremental growth, and then all of a sudden, boom, we take off. Growth hormone stimulates that. The sex hormones, estrogen and testosterone, stimulate that. When we hit puberty, we get that rapid growth in our bodies. The secondary sex characteristics appear, and we essentially, at the end of puberty, we have reached our adult stature. So whatever size we're going to be, whatever shape our bodies are going to be, we reach that adult stature. And that's been being driven by the rapid production of hormones, of protein now. So how do we make sure we get the right number of proteins from our plant foods? Well, this little chart here shows you, for example, what do you get from corn? Well, everything highlighted here in yellow from tryptophan down to leucine comes from corn. Over here, the legumes gives you everything highlighted in blue. So valine down to lysine comes from beans. So corn and beans, you need to have all of these amino acids. Corn gives you tryptophan, methionine, valine, threonine, phenylalanine, and leucine, but it doesn't give you isoleucine or lysine. Beans give you everything from valine down to lysine, but doesn't give you tryptophan and methionine. But if you eat the two together, you get everything you need. You get all of your essential amino acids by combining those two food groups. Because plant proteins are incomplete. They don't have, there is no one plant food that has all 20 amino acids. Now, what about, so those are the big three. Those are the big three major nutrients. The minor nutrients include the vitamins. They are coenzymes. They work as a coenzyme. A coenzyme is not an assistant enzyme or a wannabe enzyme. It just helps the enzyme do its job. It allows the enzyme, the protein, to do its job. It facilitates the work of the protein. So where do we get them? We get them in our diet. Vitamin D, we can get in our diet. Dairy products are enriched with vitamin D. Dairy products didn't come with vitamin D in there until 80 years ago. I don't know. It was, if you go back and look at history books, you can see that in advertising, for example, if you were selling milk at a store, one of the selling points for the milk was vitamin D added, because cow milk didn't have vitamin D, but vitamin D was added in there. Now, we also make vitamin D in our skin. When we are exposed to ultraviolet radiation, we produce vitamin D. We also get vitamin K in our colon. we have bacteria living in our colon, our large intestine, that produce vitamin K. Vitamin K helps us to clot properly. Vitamin B, there's a whole various types of vitamin B that we use, and some also gets made in our bacteria. Beta carotene. Beta carotene is what is the orange pigment that comes in carrots, for example. It is that orange pigment in there. And we convert that to vitamin A. Beta carotene is essential to a pigment in our retina called rhodopsin, and that allows us to have good night vision. It makes the rods in our eyes, the photoreceptors that respond to dim light and dark light, dim and gray, poor lighting conditions, allows us to see better, to be more sensitive to the photons of light that are there. Now, there is no one source of all vitamins. And even if you look at multivitamins, if you look at the labels of the multivitamins, they're all going to have different types of vitamins there. It's hard to find a vitamin that has everything you're looking for. You may want to have a vitamin with iron and then discover it doesn't have a lot of iodine in there. Iodine we need for our thyroid. You may find something that's high in thyroid and high in iron, but no B12, for example. So, two types of vitamins, water soluble and fat soluble. The water soluble vitamins are the B vitamins, the C vitamins, the B12 vitamins. Water soluble vitamins do not get stored. Our bodies will use what we need in the first hour and then excrete the rest. So the whole popularity of taking mega doses of vitamins is not helpful. Mega doses of, like vitamin C, for example, don't work because our body will only use what we want or what we need. The rest of it will literally go down the drain. You'll pee it away. In the 1960s, there was a great deal of research done trying to connect vitamin C to resistance to the viruses that cause the common cold. Well, take mega doses of vitamin C and you'll feel better. Well, no, you won't feel any better. In fact, you'll probably feel worse when you realize how much money you're wasting. You might as well take your vitamin C and pour it down the toilet because your body's not gaining any benefit once it reaches a certain point. Now, what about the fat solubles? They're a little more dangerous to us. Vitamin A, vitamin D, vitamin E, and vitamin K. These are all absorbed with fat. They pass across the cell membranes very easily. They all get stored in the body except for vitamin K. Vitamin K is only made in the large intestine. If some is good, too much is dangerous. High levels of vitamin E can alter the body's ability to clot properly when we bleed. Vitamin A, if some is good to help our vision in dim light, more is not necessarily better. So, and more may affect pigmentation in our skin or under the nail beds. So it isn't there is no such thing as if some is good, more is better, particularly in dealing with vitamins. So now, one of the things that vitamins are really good for us are getting rid of free radicals. Remember I said free radicals are molecules, fragments of molecules that a molecule may have broken apart, and it has a charge on it that shouldn't have. Imagine a hydrogen, the hydrogen ion coming off of a water molecule, but having a negative charge on it instead of a positive charge. Think about that for a second. It's pretty unusual. Or maybe a fragment of glucose having a positive or a negative charge. Those are free radicals that occur during metabolism. Now, vitamin C, vitamin E, and vitamin A are antioxidants that destroy this. What these free radicals do is they cause oxidation, they cause destruction of healthy cells and structures within cells. And an antioxidant prevents that. And vitamin C and E and A are good antioxidants. We get these naturally in the leafy greens, this term for like the broccoli and the cauliflower and the Brussels sprouts. Vitamin A and C, a diet high in that kind of food is going to function as an antioxidant. So will dark chocolate, and so will red wine. So you have some choices here. Anyway, and again, I can't emphasize enough the problem with mega doses of anything, mega doses of vitamins in particular. So, and let's see, minerals. Okay, yeah, let me get 2 more slides in and we'll call it a day. Minerals, 7 minerals that it's a minor nutrient. We require calcium and phosphorus, potassium, sulfur, sodium chloride, and magnesium. Calcium for bones, phosphorus for bones, potassium for potassium ions inside the cell, sodium ions outside the cell. Chloride is just sort of watching, and then magnesium, we use that for different chemical reactions. We have to have all of these minerals to function properly. We also need iron for hemoglobin, iodine to make thyroid hormone so we can regulate our metabolic activity. And while it says that sodium and chloride are major electrolytes in the blood, meaning they can have positive and negative charges, you'll learn in AP2 that chloride just doesn't get to do anything. So, okay, and this is a great place to stop. We're halfway through the chapter, and we will start talking about metabolism on Wednesday. Now, today in lab, we are going to look at joints and articulations and then start on skeletal muscle. So I promise not to drag it out too long, but I think we can get a good start on the muscles. So anyone have any questions? Okay, then I'm going to get us out of here. I'll see you at 1 o'clock.